All right, ready? Hello, Allie. Sorry you're still feeling poorly. We're going to start today by reviewing probability rules. Can you think of any rules that affect probability? They're always the same for probabilities. Like, for example, 0 is less than or equal to a probability which is less than or equal to 1. We made a box on one of our days and we had all our probability rules in it. I don't really want you to regurgitate those, but can you think of anything else that we learned that could fit as a rule for probability? What's the probability of something occurring that is in the sample space? Do you recall how that works, Caleb? Probability of something is in the sample space. Sample space, you recall, is every possibility that there is.
Oh, just probability of anything happening within sample space?
Yep.
1.
1. Very good. So that, you look back on our little box that day, that was one of the rules. I don't know if I can think of any more. What else did we learn about probability? I know. The probability, when it's mutually exclusive, I'll write down here because this one takes longer. Mutually exclusive events. What's the probability of, so say A and B are mutually exclusive, they don't overlap. What's the probability of A or? So or is our smiler. You used these yesterday with ease. You remember how we did that one, Brandon?
Is it what?
Is it what?
Like half?
It is in certain cases, but I think this is the general rule. Yes.
Probability of A plus the probability of B minus the probability of A and B.
All right. Actually, all we need for mutually exclusive is right there. So,
Mutually exclusive.
all right, because they don't overlap. But so let's do it. Since you brought it up, for non-mutually, you can find this little box somewhere. In fact, if you could, help me figure out what the two are. I can't think of. Non-mutually exclusive events, A and B, work like this. A, the probability of A happening or B happening is, you add their individual probabilities, and then you subtract that overlap part. So we had that. We have two more. Oh, thank you, Bailey. What else?
Probability of A equals number of A out.
The actual definition, right?
Yeah, and then probability of A complement.
Okay. Probability. This is not probability. It's
Number
number of A outcomes.
Or total.
Yeah. Divided by number of total outcomes. And the probability of a complement is 1 minus the probability. Alright, so these were the things that kind of pull all together, because today we're going to find some probabilities in some of our problems today, and we're going to do a probability tree. So that's our goal today. Before we jump into our tree, let's look at where we ended yesterday, and then I'll open up for questions if you have any for your assignment, and then I will teach the tree. So that's our goal for today. The tree is pretty cool because it takes those problems that have thousands of facts and it organizes them all and helps you get the answer. So I like the probability trees. You've probably seen it before. So let's see if you have or not. All right, test for independence is where we ended yesterday, and we had two events, A and B, and we happened to look at male and right-handedness, and we had to do a certain thing. Do you recall what we did? We tested the probability of A given B, and we wanted to compare that to just the probability of A. And we found out if they were the same, then we would declare that they were independent of one another. And we did that for this example. They were pretty close, so we said they were the same. Can you pick that up just to warm up and test another one? Let's do the one I did so we can get the same answers. The probability, if you would find this information's already in your notes, probability of, let's do left-handed given male. So we're not expecting that there's a relationship there that looks pretty random, but we're expecting them to be independent of one another. Does being a male make it more likely or less likely of being left-handedness? I don't think so. There might be, but I'm expecting it to be independent. So would you please take that upon yourselves to calculate that? All right, in order to, oh yeah, you know what? We have to do 2 steps on this. We have to reverse it. I don't know if we did that yesterday. Okay, thank you. I blocked it out of my memory. We have to do 2 parts. We have to do this, check this with this, and then we have to check this with this. So it's not really or, it's an and. We have to do both. All right, so get me started. All right, looking at this chart, Elena, what's the probability you find the numbers of being left-handed given you're a male? So you gotta stay here, given you're a male, whatever what.
3 out of 23.
And what how many?
3 out of
3,
23.
okay, I thought you said 4. All right, so would you give me that percentage? You can't, your calculator won't turn on. But it is here, so that's good. Where's mine? Still in the Mary Poppins bag.
Oh. It's 13%.
Here you go. All right. So, 3 out of 23 gives us what, Elena?
13%.
13%? All right. So, Julia, what do I have to test next? Can you follow what this box is asking you to do?
Then you test the probability of just A.
Which is, our example is?
And would be 3/7.
3/7. So a probability of, I'm saying, what are we looking for in our example? The probability of what? She did left-handed given male. She's doing A given B. What are you doing?
Being left-handed.
Right, just left-handed. So it is just left-handed involves
So
the
3/7.
margin. The margin. So
Yeah.
we're, how many left-handeds in the whole group?
7.
7 out of 50. Is that what you said?
No, I
Okay,
said 3
all
out
right.
of 7.
All right, so 7 out of 50 is 14%. So I would tend to say that those are the same.
In the book,
It
last
says
night
no.
it says no.
Yeah, so I thought I'd bring this out. So I'll talk about that in a second. But let's say we thought, yeah, that's pretty close. I'm going to say yes. So I'm going to
It's only
check
a
the
50
other
sample
way.
size, so I'm
Pardon?
sure.
What's that?
I know, that's what I was.
Like, that close is pretty good for a sample size of 50.
It is. So I would say yes. you
Yeah.
know. I'd say they were the same. So, but I'll talk to you about that in a minute. So let's see. Now we're going to go the other way. So Brandon, your turn. Haven't heard.
And also a
from you.
sample size that doesn't have equal numbers of
What's the
random
probability? We're going to switch A and B. So we're going to switch M and males and left-handed. Can you tell me from this little orange chart, what's the probability of being a male given you're in the left-handers column? So you're in the left-handers
So,
column.
3 out of 23.
3 out of what?
3 out of 23.
We have to stay in this
Oh,
column.
3 out of 7.
Yes. So 3 out of 7. Can you get me that percentage?
Wait.
43%. All right, back to you then. What's the last percentage, Caleb, that we have to check?
Probability of being a male.
And what is that?
46.
And it's 23 out of 50. So, yes or no, what do you say? What do you say? What do you say?
I say,
I said
I
no.
would say
There's, like you
There's
said, it's
very-
such a small sample to be that close is kind of amazing. To be that close is really amazing. But the book says to say no. The thing
book's
that
been wrong before.
I'll say at this point is the question is, how close is close? You know, when I say these are so close, let's say they're equal. Well, how close is close? 43 and 46, these are so close, let's say they're equal. So how close is close? For now, it's pretty much subjective, as so many of our decisions are, But in a few chapters, mathematically, we will be able to give you a range that says how close is.
And this doesn't fall in that range?
I don't know.
I feel like the range should be bigger.
And the calculation's not real simple, but I know how to do it, but I haven't done it. So for this example, but it involves like how big your sample size is.
Yeah, I was gonna say, wouldn't you think that
everything.
it'd be more precise
Right.
for bigger samples?
Right, so it wouldn't surprise me in this one that it was, yes, that that they are independent. So, anyway, that's where we ended yesterday. So now we're going to ask questions, anything from the assignment that we were looking at. We were asked to look at certain ones. I think we went, 57, 58, 59, 60, 63. Did we do 65?
Yeah.
Okay, that was the last one then. All right. You can hold them up if you have no questions. If you have questions, then you can ask me now. Anything now before?
Forever hold your peace.
Any questions on those?
The last one.
All right, number 65? Sure. All right, let's help Elena and maybe anyone else on 65. Takes me a good 5 minutes to find the problem, so. All right, on
Page
60.
329.
Thank you. I was in the wrong section.
The third part of it or the whole thing?
All right. I don't know. Once we
Elena?
get started, I'm sure. All right, you have to look at that chart, Elena, where it talks about a good chance of what, being rich or something.
Okay.
What is this chart about? I forget.
What are you asking?
What are you? We're looking at 65.
65 doesn't have a chart.
Oh, it doesn't? Yeah, it says
Oh, it is. Oh, never mind. It does have a chart.
revert back to 63. So that's where the chart is.
Oh,
Okay, we're already 10 minutes or 13 minutes, 12
12.
minutes. Wow. All right. Coming up again. You ready?